The Kaman K-MAX is an American helicopter with intermeshing rotors built by Kaman Aircraft. It is optimized for external cargo load operations, and is able to lift a payload of over 6,000 pounds, which is more than the helicopter's empty weight. A remote-controlled unmanned aerial vehicle version is being developed and is being evaluated in extended practical service in the war in Afghanistan. In June 2015, Kaman announced restarting the K-MAX production due to 10 commercial orders. First deliveries are planned early 2017. Development. In 1947, Anton Flettner, a former German teacher and inventor, was brought to the United States as part of Operation Paperclip. He was the developer of the two earliest syncropter designs from Germany during World War II, the Flettner Floor 265, which pioneered the syncropter layout, and the slightly later Flettner Floor 282 Colibri, intended for eventual production. Both designs used the principle of counter-rotating side-by-side intermeshing rotors, as the means to solve the problem of torque compensation, normally countered in singly Euro-rotor helicopters by a tail rotor, fenestron, NOTAR, or vented blower exhaust. Flettner remained in the United States and became the chief designer of the Kaman Company. He started to design new helicopters, using the Flettner double rotor. The K-MAX series are the latest in a long line of Kaman syncropters, the most famous of which is the HH-43 Husky. The first turbine-powered helicopter was also a Kaman syncropter. The K-1200 K-MAX aerial truck is the world's first helicopter specifically designed, tested, and certified for repetitive external lift operations and vertical reference flight, an important feature for external load work. Other rotorcraft used for these tasks are adapted from general-purpose helicopters, or those intended to primarily carry passengers or internal cargo. The K-MAX can lift almost twice as much as the Bell 205 using about the same engine. The aircraft's narrow, wedge-shaped profile and bulging side windows give the pilot a good view of the load looking out from either side of the aircraft. The transmission has a reduction ratio of 24:1 in 3 stages, and is designed for unlimited life. The rotor blades are built with a wooden spar and fiberglass trailing edge sections. Wood was chosen for its damage tolerance, fatigue resistance, and to take advantage of field experience and qualification data amassed from a similar spar on the HH-43 helicopter, built for the U.S. Air Force in the 1950s and 1960s. The pilot controls blade pitch with tubes running inside the mast and rotor blades to move servo flaps that pitch the blades, reducing required force and avoiding the added weight, cost and maintenance of hydraulic controls. The K-MAX relies on 2 primary advantages of syncropters over conventional helicopters: the increased efficiency compared to conventional rotor lift technology, and the syncropter's natural tendency to hover. This increases stability, especially for precision work in placing suspended loads. At the same time, the syncropter is more responsive to pilot control inputs, making it possible to easily swing a load, or to scatter seed, chemicals, or water over a larger area. A K-MAX has been used for demolition work by having a wrecking ball as a slung load. 38 K-1200 K-MAX helicopters have been built. As of January 2015, 11 of these were not airworthy or have been written off in accidents, 5 are in limbo at Kaman, and in March 2015 the number of operational K-MAXes was 21. The production line was shut down in 2003, but may restart if the U.S. Marine Corps orders more autonomous K-MAXes. In February 2014, Kaman revisited the idea of resuming K-MAX production, having recently received over 20 inquiries for firefighting, logging or industry transport requirements additionally to requests for the military unmanned version. 10 firm orders may convince Kaman to produce K-MAX again. Kaman has received deposits, and if enough orders come through, deliveries could occur by 2017. The K-MAX line has flown 300,000 hours as of 2014, and costs $1,200 per flight hour to operate. Unmanned remote control version Kaman has been developing the unmanned K-MAX since 1998. In March 2007, Kaman and Lockheed Martin signed a strategic relationship agreement to pursue U.S. DoD opportunities. an unmanned mostly autonomously flying, optionally remote-controlled and optionally piloted vehicle version, the K-MAX unmanned multi-mission helicopter, was developed for hazardous missions. It can be used in combat to deliver supplies to the battlefield, as well as civilian situations involving chemical, biological, or radiological hazards. A prototype of this was shown in 2008 for potential military heavy lift resupply use, and again in 2010. In December 2010 the Naval Air Systems Command awarded a $46 million contract to Kaman for 2 aircraft, and in 2011 they completed a 5-day quick reaction assessment. In December 2011 an unmanned K-MAX was reported to be at work in Afghanistan. On December 17, 2011, the U.S. Marine Corps conducted the first unmanned aerial system cargo delivery in a combat zone using an unmanned version of the Kaman K-MAX. The unmanned K-MAX moved about 3,500 pounds of food and supplies to troops at Combat Outpost Payne. As of February 2013, the K-MAX had delivered £2 million of cargo in 600 unmanned missions over more than 700 flight hours. A third unmanned K-MAX, based in the U.S., was tested in 2012 to deliver cargo to a small homing beacon with 3-meter precision. On July 31, 2012, Lockheed announced a second service extension for the K-MAX in Afghanistan for the Marines. This extended operations to the end of March 2013, with the option to extend to the end of September 2013. On March 18, 2013, the Marine Corps extended its use of the unmanned K-MAX helicopters indefinitely. The Corps does not currently have plans to buy more, but the 2 aircraft in use would remain until otherwise directed. At the time of the announcement, they had flown over 1,000 missions and hauled over £3 million of supplies. Assessments for their use after deployment are being studied. While proving useful, their niche in future Marine Corps aviation is not yet clear. The unmanned K-MAX has won awards from Popular Science and Aviation Week and Space Technology, and was nominated for the 2012 Collier Trophy. On June 5, 2013, one of the unmanned K-MAX helicopters crashed in Afghanistan while resupplying Marines. No injuries occurred and the crash was investigated. Pilot error was ruled out, as the aircraft was flying autonomously to a predetermined point. The crash happened during the final stages of cargo delivery. Operational flights of the remaining unmanned K-MAX were suspended following the crash. On August 14, 2013, the Navy said the K-MAX could resume flying by the following week, with the final decision resting with operational commanders. The week before, the K-MAX flew 16 hours. Swing load was seen as the prime cause of the crash. The Marine Corps is considering turning the K-MAX into a program of record, with possible uses including ship-to-shore deliveries. The investigation determined that the crash was not caused by mechanical problems, but by unexpected tailwinds. As the helicopter was making a routine food delivery, it experienced tailwinds instead of headwinds, causing it to begin oscillating. Operators employed a weather vane effect to try and regain control, but its 2,000 pounds load began to swing, which exacerbated the effect and caused it to contact the ground. The crash report determined that it could have been prevented if pilots intervened earlier and mission plan received updated weather reports. Diverging conditions and insufficient programming meant it could not recover on its own and required human intervention. At the 2013 Paris Air Show, Kaman promoted the unmanned K-MAX to foreign buyers. Several countries have reportedly expressed interest in the system. The K-MAX supporting Marines in Afghanistan was planned to remain in use there until at least August 2014. The Marine Corps is looking into acquiring the unmanned K-MAX as a program of record, and the U.S. Army is also looking into it to determine cost-effectiveness. If it is accepted into service, the adapted commercial rotorcraft would re-enter production and Kaman would reopen the facility to build it. Lockheed and Kaman estimate re-establishing the line would take 9 months, with the first aircraft delivered 3 months later. In theater, the unmanned K-MAX performed most missions at night and successfully lifted loads of up to 4,500 pounds. Hookups of equipment were performed in concert with individuals on the ground, but Lockheed is looking into performing this action automatically. It is building a device to be mounted atop the package that the helicopter can hook up to by itself, and this feature was demonstrated in 2013. Other features are being examined, including the ability to be automatically rerouted in flight, and to fly in formation with other aircraft. The House Armed Services Committee has shown its support for the unmanned K-MAX. It has urged the Army to look into the cargo UAV concept, as 30,000 pounds of cargo was successfully delivered in one day over the course of 6 missions transported cargo per mission. Lockheed and Kaman have discussed the purchasing of 16 helicopters with the Navy and Marine Corps for a baseline start to the program. The unmanned K-MAX is competing with the Boeing H-6U Little Bird for the Marine Corps unmanned lift ISR capability. Evaluations of the 2 helicopters were to begin in February 2014 at Marine Corps Base Quantico. Marines at Quantico successfully landed an unmanned K-MAX, as well as a Little Bird, autonomously using an iPad-like mini tablet. The helicopters were equipped with autonomous aerial cargo utility system technology, which combines advanced algorithms with LiDAR and electro-optical infrared sensors to enable a user to select a point to land the helicopter at an unprepared landing site. Autonomous landing without the need for remote control or TL operation reduces operator burden and allows resupply missions, or other missions like medical evacuation around the clock. The AAC-US weighs 100 pounds, so it can be easily integrated onto other aircraft like the CH-53E Super Stallion and V-22 Osprey. Operational use of the system could be possible within 2 years. Both unmanned K-MAX helicopters in use by the Marine Corps returned to the United States in May 2014, when the Corps determined that they were no longer needed to support missions in Afghanistan. After deploying in December 2011, originally planned for 6 months, it stayed for almost 3 years and lifted 2,250 tons of cargo. The aircraft was sent to Lockheed's Oswego facility in New York, while the service contemplated the possibility of turning the unmanned K-MAX from a proof-of-concept project into a program of record. Formal requirements for unmanned aerial cargo delivery are being written to address expected future threats, including electronic attack, cyber warfare, and effective hostile fire. These were avoided in Afghanistan quickly and cheaply by flying at night at high altitudes against an enemy with no signal degradation capabilities. Officials are assessing the K-MAX model that crashed and plan to repair it in 2015. Until then, the helicopters, ground control stations, and additional equipment will be stored at Lockheed's facility in Oswego. Renewed flight demonstrations were planned for 2015 to show their continued utility for Marine Corps missions, including small unit responses and amphibious operations in the Pacific Theater. Lockheed Martin demonstrated a firefighting version in November 2014, and again in October 2015, when it delivered over 24,000 pounds water in 1 hour. A casualty evacuation exercise was performed in March 2015 in coordination with an unmanned ground vehicle and mission planning system. A medic launched the UGV to evaluate the casualty, then used a tablet to call in and automatically land the K-MAX. The medics strapped a mannequin to a seat aboard the helicopter, which then flew to a safe area. The 2 unmanned K-MAXs, designated the CQ-24A, were to be moved to a Marine Corps base in Arizona by the end of September 2015 to develop tactics and operations concepts to inform an official program of record for a cargo UAV. Lockheed continues to favor the K-MAX as their platform offering, and an aircraft could enter service by 2022. Operators: Colombia, Colombian National Army Aviation, Germany, HELOG, New Zealand, Skywork Helicopters Limited. Peru, Peruvian National Police, Switzerland, Rotex Helicopter AG, United States, Central Copters, Incorporated. Helic Est International, Swanson Group Aviation, Timberline Helicopters, Incorporated. United States Marine Corps. Specifications. Data from K-MAX performance and specs, general characteristics, crew, 1, capacity. 6,000 pounds external load, length, 51 feet 10 inches, Rotor diameter, 48 feet 3 in, height, 13 feet 7 in, empty weight, 5,145 pounds, useful load, 6,855 pounds, max takeoff weight, 12,000 pounds, performance, maximum speed, 100 knots, cruise speed, 80 knots, range, 267 nanometers, service ceiling, 15,000 feet, fuel consumption, 85 gallons per hour. See also, related development, HH-43 Husky, aircraft of comparable role, configuration and era, Kaman K-26, Kaman K-226. References. External links, Kaman Aerospace's K-MAX page, Superior helicopter K-MAX with Fire-MAX system, Austrian Wucher helicopter, economy of heli logging with K-MAX, video of a K-MAX starting up.